Let's try to do this problem that's based on the colligative property and the vapor pressure to be more specific. It says how many grams of glucose a student must add to 400 grams of water to make an aqueous solution with vapor pressure of 14.0 mm of mercury, and you're provided the pure vapor pressure of water. So you want to make sure you know what terms you're given and also start out with what formula you're going to be using or what formula is for the vapor pressure for the solution and the pure vapor pressure. So the vapor pressure of a solution is going to be equal to the pure vapor pressure and times the mole fraction of the water. So we know the pure vapor pressure to be 17.5 mm of mercury, and we are also provided the vapor pressure of the resulting solution, which is 14.0 mm of mercury. And then we try to figure out how much glucose needs to be added. So one of the ways you can kind of start out your problem here is by figuring out what the mole fraction going to be. So the mole fraction of water here is going to be equal to pressure over vapor pressure of solution divided by the pure vapor pressure. So just rearrange that equation there, divide both sides by pure vapor pressure. So it's going to be 14.0 mm of mercury divided by 17.5 mm of mercury. That comes out to be 0.80. So that's going to be the mole fraction of the water. Um, you do know how much water you're using. You're using 400 grams of water. So if I elaborate the definition of the mole fraction of water here, it's going to be the moles of water divided by the moles of the water plus the moles of your glucose. Because remember, it's going to be the total moles. So if I know everything here, I can figure out what the moles going to be for the glucose. And once I know the moles of glucose, I can figure out how many grams of glucose must be added here. Well, first go ahead and figure out how many moles of water we have because we were given 400 grams of water. So we got 400 grams of water, and I know to figure out the moles from the mass, we're going to be using the molar mass of water, and 1 mole of H2O is going to be 18.01 grams of water. So that's going to be 400 divided by 18.01. So that's 22.21 moles of H2O. And then let's go ahead and figure out the moles of glucose here. So your mole fraction is given to be 0.8. It's 22.21 divided by 22.21 plus the glucose is what we're trying to figure out. So just leave that as N of the glucose. So just do the math however you want to do it. So what I would do, I will do a cross multiplication there where I would have 22.21 plus the moles of glucose. And that's going to be equal to 22.21 divided by 0.8. So 22.21 divided by 0.8 is going to be 27.76, and then the moles of glucose here would be 27.76 minus 22.21. So it's going to be 5.55. And then once you know the moles, we can go ahead and use the molar mass to figure out what's going to be the mass of the glucose. So we're starting out with 5.55 moles of glucose. And then what's the molar mass of glucose? Well, if you're not provided the molar mass of glucose, you know the formula, which is C6H12O6. So from there, you can figure out the formula. So we got 6 carbons, so 6 times 12, and then We have 12 hydrogens plus 12. Each hydrogen is going to be about 1. And then we got 6 oxygen. So that's going to be roughly 180. So it's going to be 180 grams divided by 1 mole. And let's see what that comes out to be. So 180 times 5.55. So it's going to be 999 grams of glucose. So that's how much glucose needs to be added to have that vapor pressure decreases by that much amount. If you have any confusions on this question, feel free to leave any comments in the section below.